What is bioremediation? Bioremediation is basically use of the bacteria, fungi or plant to break down the chemical compound that accumulated in the environment. There are three types of bioremediation, namely bacterial bioremediation, phytoremediation and mesoremediation. So our journal is focused on mesoremediation. Let's have a look of it. The objective of this study is for the part of the methodology, it has been started with the soil sampling. Secondly, the cultivation of the mushroom grain spawns. Thirdly, the determination of the mycorrhizal infection. Fourthly, isolation of the mycorrhizal spores. Then, the extraction of the mycelial cell from the Pleurotus pulmonarius. And finally, the experimental design.
Here are the results. The collected data was recorded in tables. Table 2 shows the mean plant height of Amaranthus Hybridus treated with different crude oil concentrations. Table 3 shows the mean leaf area of Amaranthus Hybridus treated with different crude oil concentrations. The leaf area was calculated by this formula. Leaf area equal to length times width times 2.325 in centimeter square. Table 4 shows mean number of leaves of Amaranthus Hybridus treated with different crude oil concentrations. Next, here are the graphs that was created from tables so that we can differentiate the results. Figure 1 shows the mean plant height for different samples at the various concentration of crudes. The y-axis is the mean of the plant height. The x-axis is the sample 1 to 9. The colored bar here shows the concentration of the crude oil. The blue color represents 0% of crude oil, while the green, white, and purple represent 2%, 3%, and 4% of concentration of crude oil respectively. Amaranthus plant showed better growth in sterilized soil polluted with crude oil than unsterilized soils. Samples 1 and 2, which were sterilized and unsterilized soil, showed the best growth among the sample treated. This indicates the fact that presence of crude oil at any percentage concentration is a possible pollution indicator. While polluted samples treated with Glomus Mosseae, sample 3 and 4, crude best when compared to other samples grown on crude oil, polluted soil without Glomus Mosseae treatment. Figure 2 shows the mean number of leaves for different samples at the various concentration of crude. And figure 3 shows mean leaf area for different samples at the various concentration of crude.
Based on the findings of this research, all the samples show some groups have indicated that at any concentration include 0% are possible to be the indicator of pollution of crude oil. Samples 3 and 4 were treated with Glomus Mosseae treatment showed the best growth compared to those that untreated. According to Abedian 2010, this is because of the effect of mycorrhizae to the plants to overcome the pollutions from crude oil. Briefly, it addresses the uptake of nutrients to the plants, particularly phosphorus, for cell wall formations, and involved in the cellular respiration includes the metabolism of the plants. The same explanations relates to the ability to cope with physiological stress, where samples 7 and 8 were treated with mycelium of Pulmonarius showed fine data graph at different concentration of crude oil. Also, the addition of SMC to the soil causes the plant to grow better at high crude oil concentration that can be referred to table 2, 3, and 4 in the general chart that at low crude oil concentration of samples 5 and 6. Then basically, when translated to the graph of plant height at 4% of crude oil pollution level was better than at 2% crude oil concentration referred from figure 1, 2, and 3. The greater the carbon content, the greater the level of organic pollutants present in the samples. Same goes as the lower the percent total carbon present in the sample, the lower the presence of organic compounds in that sample. From there, the regression analysis revealed that the percent total carbon decrease in crude oil pollutant soils treated with mycelium of Pulmonarius and SMC with Pulmonarius. In the other hand, apparently the samples that were planted only with sterilized soil that had the best crop due to the lack of competitors and others treated some sort of attrition compared with unsterilized soils. Sample 9 at a different concentration resulted of death within 2 weeks as they were susceptible to contamination.
The growth of Amaranthus Hybridus with 9 different treatments which include sterilized and unsterilized soil, crude oil, mycorrhiza, mycelium of the mushroom and spent mushroom compost has been studied. According to the study, it has been found that the edible root fungus Pleurotus pulmonarius to be a potential bioremediating agent due to its ability to degrade crude oil. In addition to that, the study also highlights that the mycelium as well as spent mushroom compost of Pleurotus pulmonarius are useful tools in the process of crude oil polluted soil bioremediation. The spent mushroom compost is derived from the recycled process of sawdust which can be used to grow the mushroom. Based on the results, it can be observed that Glomus Mosseae, an arbuscular mycorrhiza fungus, helps to biostimulate a crude oil polluted soil undergo bioremediation. This helps to alleviate nutritional stress and protect Amaranthus hybridus against harmful effect of crude oil pollution. Throughout the study, both Pleurotus pulmonarius and Glomus Mosseae show promising results in order to enhance crop productivity in polluted environment. This can eventually lead to poverty alleviation and aid food security. However, more research is still needed in this subject as it is closely related with in situ application and long-term studies of the associated crops and soil types.
In this reflection segment, we will discuss on the benefits, the limitations of the technique used, and the improvements, the improvisation that can be done to this technique. In this study, it shows that the use of biological and physical treatment to treat the contaminated soil and groundwater is effective in improving the land use for vegetation and plant health, yield, and growth. Now, let us discuss in detail. It is known that bioremediation is a natural process. It degrades the contaminants, increases the numbers, and releases harmless products. The residues for the treatment are usually harmless, products such as carbon dioxide, water, and cell biomass. Secondly, it is very useful for the complete destruction of a wide variety of contaminants. Many hazardous compounds can be transformed into harmless products. This reduces the chance of future liability associated with the treatment and disposal of contaminated material. Moreover, it also can be carried out on the site of contamination itself without causing a major disruption of normal activities. This removes the need to transport huge quantities of waste off-site and thus reduce potential harm to human health and the environment that can be arises during transportation. Although the technique that have been used in this article proved to be very beneficial, it also has a few limitations. The first one is the specificity. Biological processes are highly specific. It is crucial to have a compatible, multiplically capable microbial population, suitable environmental growth and conditions, and appropriate levels of nutrient and contaminants. Secondly, the technical advancement. It is very crucial and essential to have advanced technologies to fit with the complete mixes of contaminants that are not evenly distributed in the environment. Moreover, it is a very time-taking process. Bioremediation usually takes a longer time when compared to other treatment options, such as excavation and removal of contaminants from the sites. Lastly, the regularity and certainty. There are no definite confirmation if the applied remediation treatment is 100% complete, since there is no accepted definition of clean. Hence, a precise evaluation of bioremediation is quite difficult. Now, let us discuss on the improvement that can be done to cover up a few limitations that can be found in this technique. The first one is the evolution of degradation capacity in contaminated soils. This can be achieved with sufficient time and sufficient favorable condition. The capacity to degrade any organic compound is likely to evolve or might immigrate to a contaminated site. Second, the application of genetic engineering for strand construction. Bacteria can be modified genetically for a multitude of purposes, include degrading capability, Bacteria may be modified to recognize and become induced by compounds. Once induced, the gene product degrades the contaminants.
Thirdly, a degradation capability on conjugative plasmids. Introducing degradation capability on conjugative plasmids to have capacity to degrade various small unnecessary constituent compounds. And lastly, rhizosphere bioremediation. The roots of the plants penetrate into the soil, changing locally the condition in the rhizosphere and mycorrhizosphere. The roots themselves are colonized by bacteria or mycorrhiza forming fungi, in which the fungal hyphae are more or less densely colonized.